Okay, guys, I just actually designed a system or mechanical system that can actually create a time bubble. The way it works is basically we know that Earth's gravity uh, underneath Earth itself, it bends time and space just like a blanket. You know, all the planets and solar system and the sun, they're like marbles on top of a blanket, and it warps the bottom of the time and space. Anyway, because of the mass. So if an object can become uh, a greater mass, it would affect time and space. Well, anyway, I designed a machine that can do that. It's very simple. It's just common sense. Um, the simplest to increase the mass of an object to a higher mass greater than Earth's gravity, and by then affecting time and space, in this case creating a time bubble. It's a very simple machine, and this is the way it works. If you have a machine that it's just a concept, it's just for this number, so just for example purposes. They're not actual precise numbers. So in this case, I have a motor spinning at 3,500 RPMs, or let's say its G-forces at 2,058. So that's the G-forces. Then on top of it, you have another motor. It has an individual motor and an individual power source. And then same thing, it spins at 3,500 RPMs and also at 2,058 Gs. And therefore, you add more cumulative motors on top of it. So yeah, in this case, you have six for training purposes. Let's say it's eight. So now you have eight motors, and each one is spinning at 3,500 RPMs. Each individual motor with its own power and own engine, uh, and pretty much they're all spinning. So this one's spinning 3,500, and this one's spinning 3,500, and so on. So now you have accumulative RPMs. So you add all the individual engines with this own individual power source, each one spinning at 3,500. Let's say you have eight engines, you multiply 3,000 by 500, and then you get 28,000 RPMs right here. So, so each individual RPMs becomes accumulative. You add that to your speed velocity. Also, if you have the G-forces, let's say you have a G-forces 2058 Gs, and by each engine, it does the same thing, 2058. So now you got 2058 Gs multiplied by eight engines, right? And then uh, you get 16,464 Gs. Okay, so you know each one single G equals to Earth's gravity. So let's say you're 100 pounds, right? And you're in Earth's gravity, so that's one G, so you're 100 pounds. But if you're two Gs, now two Gs will equals twice of Earth's gravity. So if you get 100 pounds, multiply that by two, and that equals 200 Gs. 200 Gs, I'm sorry, 200 pounds. So now if you have 100 pounds and you have a total of 16,000, okay, so if you have a total of 16,464 accumulative Gs, because you add all the eight motors, and you multiply that by 100 pounds, and that gives you how much weight of an object. So I have circles here. Each circle is a weight. For an example, let's say it's 100 pounds here, but anyway, let's say this is a ton. Let's pretend this is a ton object that weighs a ton, and you multiply 1 ton by 16,464 Gs, and that's how many tons this is going to be. 1 ton is going to equal 16,464 tons. See what I'm saying? So that 1 ton is multiplied by how many G's? So 1 ton multiplied by 16,464 tons. That's the answer right there. So you can multiply, and basically the G's will increase the gravity and the weight of the object. So this is 1 ton, multiply with that, and equals that. So let's say this is 16,464 um, uh, Earth's gravity. So in other words, there's just like adding 16,464 planets together, each one of equivalent to Earth combined equally at 16,464 G's or Earth's gravities. So that's a higher gravity than Earth by that number. And then you have this is an entire system. And then you have opposite system over here, which is not, I didn't draw it, but it's almost identical to this. This is one complete system. And then you have another one complete system right here, and you get them close together, not too close, but how about space in between, like that, space in between like this, and inside you create a time bubble. Just like in space, in a black hole, if you get trapped into a gravitational field and you're in there, time slows down. The closer you get to the event horizon inside the black hole, time gets slow. It slows down. So the intensity also gets increased. So you slow down more and more and more as you get closer to the event horizon. But if you do get to the event horizon, time stops. That's why the black hole is called the frozen star, because time freezes, completely stops. So if a space vehicle gets trapped in the actual gravitational field, obviously, let's say they're stuck there for a minute and they get out, that minute may actually slow them down. They were stuck in there for 1 minute, but their time was so slow that 1 minute could equal, in theory, it could be just for example purposes, that 1 minute may equal 1 year in real time. So when they get out and they escape the gravitational field and they go into our own time zone, basically outside the black hole, they might find out they're actually a year into the future if they spend 1 minute, because their time actually slowed down depending how far they were into it. You remember, like I said, event horizon actually time freezes, stops. But anyway, the reason that works because the black hole attracts matter, attracts planets. Anything attracts matter to matter. Anything attracts matter creates a time bubble where time slows down. So here we have two masses higher than Earth's. These are compressed. Their molecular level it gets heavier. Just imagine a quarter being the same height, same weight as a maybe a ton or a vehicle, a truck. So imagine you having holding a quarter in your hand, and that quarter has the same equivalent weight as a truck. And that's because it's spinning so fast that the molecules get heavier and heavier, and the object becomes heavy. So same thing, as they spin, they create g-forces, and g-forces actually increase the weight of an object. So whether it be human or object or material, that object or material will become heavier and heavier every time the g-forces increase. So the object, that quarter, maybe a ton in weight, but if it's more than that, this can be higher than Earth's gravity. We're not talking a regular quarter. Quarter is a couple ounces or less, but it's something that a quarter, but it has so much energy that weights more because it's spinning g-forces. It makes it heavier. Then you have that gravity that's heavier than Earth. Remember, if a planet can actually bend time underneath the planet by like a marble on top of a blanket, imagine a mass that's spinning at that mass, and it's higher than Earth's gravity. It's heavy. Its mass is heavier than Earth. So you have this object here, which is extremely heavy, and you have this object which is heavy, and both attract. Matter and matter attracts. Remember that. So if this attracts, but you keep them separated and don't get them together, then you have a time bubble. And anybody or anything in that time bubble, time slows down. So if you walk into a time bubble, and let's say you spend a minute there, may be actually a minute to you, but when you come out, you may be an hour into the future, because while you were in there, time slowed down and everything else went by speeding fast. So an average speed. So if you stuck there for an hour, it might be a year. When you come out, you notice you're a year into the future. So this is a time machine concept as well. But this serves a lot of purposes. This invention is a multi-invention. It has different purposes and for different technologies. But right now, I'm presenting this as a time machine concept because the mass is heavier on both sides, and it creates a time bubble. So this is a time bubble machine.